Ooh, I'm not really used to this, so just a second while I adjust the camera feed, if I can, to reorient this. Hmm, What would this be? There's screen share, there's share. It looks like it's picking up my voice. I don't really know how loud it is for you. Uh, let's talk about something though. We'll dive right into it. There's this possibility. No, it seems like with the validity of AI systems that there's something that we all should really be thinking about. And I'm ready to approach PNNL, Pacific Northwest National Lab, up here in the Pacific Northwest, and maybe work on getting their level of credibility where they wouldn't pay me, but they would help with prototyping, for example. Uh, but the thing is at this point, I think that I can share with you enough devices that are already around to showcase the feasibility. And so I think that I'd rather share with humanity than withhold. And so I seems like the right thing to do, right? Uh, let's think about a magnet, right? I don't know how many of you are into the science of materials. When you have a magnet, and it's usually metal, right? Just a simple magnet, you have these clusters of nodes. And these nodes within it are a little amorphous because it's not a crystalline structure. And because it's amorphous, they have their own trajectories on what their polarity is. And so when you look at a magnet, we're usually considering just the average overall on its performance. And that's useful. Uh, and an electromagnet, we know, is similar to a magnet, but we can excite it. And when we excite it, it goes from not being a magnet to suddenly being one, right? Well, we can trigger excitations using radio waves. And so when you think about it, if you have a lattice of metal and there's arc gaps within it, or if you want to consider it a coil for your radio analogy, you could. Uh, but with these arc gaps in this lattice, you can make patterns by knowing what the waves will be like when it reaches that. But you're thinking, well, how would you ever control the waves over a given volume of space? Not it's like space time or space. I'm kind of trying to make it general. It's complicated because some people consider space like the emptiness between two things, or some people consider space to be like basically the universe or something like that. And so I want to be careful with the term space and space time just to keep this simple and maybe try to brush this aside for now. But what's important is we think about those EM waves propagating through this material. And if you want something to research for how that part's done, look at phased array radar. Phased array radar uses these tools, but it's not the same thing. A phased array radar station could be considered kind of like a starter, where it would initialize this component, this device, this radio magnet, and you could decide how it should steer the environment around it. So it could be just radio waves that are just naturally occurring, nature, or it could just be standard transmissions that are going throughout the universe. And this device can just subtly make these patterns happen. It makes for interference patterns that can cross cancel for both constructive behavior or destructive behavior. And so it's something to be considered. The strength of which the device can operate relative to its surrounding is super important. How far out and how much it can do that far out is determined by the amount of the system working in coordination. And I think a great way to consider the coordination of a radio magnet or a bunch of them is to consider it a coherence engine, putting clusters together. And the reason why it's a coherence engine is because this stuff works better when there's more of it. And so it's like an orchestra. The more players you have, the more they build up on one another, and the better you can have a wide gambit to make the sounds travel to a person that you would hope they'd hear. Now, why don't we consider, I guess, some of the applications of this? My favorite application of this is on the external surface of a vessel. It becomes something that can be ready for signals like communications. It could be something ready to shield stuff like cosmic radiation. It can be something that works to subtly distort the waves around it to where you don't see something. And this is over a volume, a classic volume where you get to decide, okay, well, over there. If you want to think about it more technically, then you have the rigors of space-time. EM waves propagate within the defined bounds of intercepts of those gravitational waves, right? Well, I might not have said that 100% accurate. I'm taxed out right now just thinking about this and trying to share it right now. So consider how those gravitational waves can influence a initialization of an EM wave, kind of like how you can propagate energy out and it can create a photon at a given point, or you can see things like the cross-canceling nature, like the double slit experiment, and you can then get an idea of the range of possibilities. There was a time I kind of wanted to call it a unison rally signal, right? Because I was thinking people would be coordinating together to work in unison to basically share knowledge on what is consistently happening. Because if you share knowledge on what's consistently happening, then other devices can be prepared for things that would break the signal. And so your Wi-Fi and Bluetooth and air comms, right? AirDropper, all the other subtle IR sensors like your remote control and all of that. All of this stuff can be used for both signaling and communication. And as we know, it subtly transfers, subtly transfers energy, right? And right now, it's generally a waste of energy because we're sending those signals in many directions. But the idea here is we can, over time, leverage this concept to not send out that signal in all directions. It makes directional energy transmission, it's redirecting the energy, it's not creating it, possible. And there's a lot of challenges in considering it, but imagine how the data in transit, all of these waves that are propagating, is the communication potential. And so coherence makes a signal from the noise. And when we understand what the noise should be like or is, then we can decide how to, not decide how to, but and we can see those signals within that system. Uh, Man, there's so many words at zero. uh, what else should I talk about? I'd like to pursue that. I know a project manager who's thinking about retiring from out there. I worked with him. I was an intern to a project manager out there at PNNL many years ago, probably maybe a decade, 1.7 or something like that. And when I was out there, they offered me a position drafting, you know, in AutoCAD systems or something like that, where it would be like, but they only invited me to two-dimensionally draft. I would just be working on planes, right? Or like circuitry and documenting where things are, like creating a flat map. And in high school, I wanted to do that 3D stuff, working in SolidWorks, conjoining components so they would stick together on lines, planes, and edges, and how you can get that structure to work together to move. It was a sweet system. I regret not continuing to practice it. That's what's exciting about going back to PNNL potentially, and working with my peers to help make this a more typical way of thinking about things, because there's so much potential here that people who are strongly worried about energy crisis in the distant future or the near future could consider the value of using these super cheap materials. You need conductors, just strands of metal wire or any kind of conductor. The superconductor might be able to do it. At the moment, I'm not sure. I haven't considered it recently. So you might want to think about the benefits of it. And if you want to consider that technical aspect, imagine how resistance changes across an arc gap relative to its velocity in the universe. And you can use that technique within the computational system to make it more clear. I guess I should say, don't overlook that part. Maybe as a reminder to myself later. I was thinking about calling it MyC cubes. It's a lot like those three-dimensional LEDs. You don't see those in very many places, so you might have to look up what that is. But you get these LED bulbs in a three-dimensional array. And what's kind of cool about this, consider this an analog or a simile, whatever the right term is for that. If you have this box of LEDs where you have you can kind of see through it, and you might be able to see this kind of pattern of LEDs. It no longer is like a communicator, like a one person, just like a flashing smoke. This becomes almost like understanding the language of fire from a distance, and knowing how someone could make a fire with two peaks, and they could be positioned with subtle peaks here, here, and here, if you know how to make a good fire. It's useful to think of those QR systems, right? QR systems is a language of programming where the relative coordinates of where those points are and what's anticipated, kind of like with what's anticipated. Here, I'm going to get this right. Coherence engine, that's what I wanted to say. makes it possible to look back on what it would be like to have this radio magnet and think towards, okay, well, this is a three-dimensional processing tree. So it's it's got a ton of potential in instrumentation. This is definitely good for metrology. It's not meteorology, which is a study of weather. Metrology is the study of precision instrumentation. And if we want to go down that avenue for a few, uh, think of one cube having the potential of like every single LED or every single intercept of arc gaps is a what's the term for it? I'm losing myself from not pacing myself properly on talking about this. Hmm. With these gaps and this potential, kind of like those LEDs, you can use that science of a 3D computational processor to justify putting packets of this material also maybe within a device if you want to. At the time, we're not at the point where we have a strong enough handle on the accuracy with our instrumentation to make this super useful with a phased array radar station or something like that, and enough of this metamaterial to it has its useful strength with the amount of energy that happens at each one of those intercepts and how well we get it to coordinate. uh, I'm so bad at keeping track of this topic at the moment of what I'm talking about. uh, all right, getting back to it. If this was a small device, like within your cell phone, we're used to a wireless transmission occurring with that coil of wire within a device and its usefulness and transmitting power locally. But there's a lot of that power that's just sent out that doesn't work right. Well, it's not that it works wrong, it's just too far from the device to be useful, the energy that goes in the other directions. So it might be worth thinking about putting this material into devices to then send that signal out in a direction. If it's anticipated, then it can be designed for better. And I kind of think they already do that with wireless charging. Isn't there kind of a stronger signal that happens towards the top side, uh, which is like considering a single axis or a timeline of this versus considering what it would be like to have all three axes, orthogonal, uh, and then utilize that concept with those three axes orthogonal to have this be something like a modem, uh, but with a lot more potential utility for control. Not that it's stronger, more like easier to conceptualize, at least in my mind, at this point. I've been working on this mostly the I started getting a strong impression that this is definitely worth pursuing about 10 months ago. And I started documenting it with a lot of fun analogies and all of that. And it started getting a little bit too childish. And so I needed to go on a hiatus because people who were reading it, they just don't really feel like they understand it. And it's tough on me because then I don't know whether or not I should pursue it. When I sense that, it's a little bit discouraging. Uh, so finding avenues to continue through that, or at least make it more clear on how to discuss this, is what I'm working on. That's why this new way of thinking about it, with the starter being like a phased array radar station. You know how you can start an ICE reciprocating engine, not only with the starter, but by pushing it and jump starting it via the starting to use it. So what I'm trying to say is phased array radar, or a starter motor itself, is a great way to think of maybe the most practical way of starting it, or maybe the most feasible way with what's around. But if you happen to be on a hill and your car is pointing down, it might be just slightly easier to let off the brake and just let it jumpstart. And so there is other ways to control this. You could think of what it would be like to have this on a tabletop with like a Raspberry Pi and a cross intercept lattice, and what you might be able to start doing to test for capability. Seems like something like this is so useful to explore with so many different ways of thought and with so many different people, uh, utilizing it with their knowledge of what they want to apply it to. Uh, and it's so much so that why not let them go ahead and build out humanity to be that much stronger to the point where we might have some tremendous well, it already seems like we got a lot of tremendous capabilities and potential. So for now, we can keep dodging those storms and helping one another through those rigors and work towards knowing how to better signal. It's really important. I guess I'll just go ahead and end the stream here and hope you have a good day. Or everything in, towards that. Have a good life. Or try to think of what it might be like once we've solved a lot of problems, to what it would be like to tune a person and subtly over time see if we can regress the look of aging. I don't know. It's with the minutia of what we are comprised of, being that of nature and all of those materials around it, including the energy in between. By being prepared for situations, we can then constantly have a subtle influence that promotes what helps us all. And so I think that, well, let's just go ahead and go back to the science so we don't get too excited to get this accomplished. And uh, yeah, enjoy. Better said.